Alrighty, Jacob, as always, thank you so much. And keep in mind, it is Monday, so that means we get to bring you another Wise Guy segment. And this is a holiday-themed segment. Joining us, Paul Kwiat, who is here to demonstrate what he just told me, tinsel tricks, right?
Tinsel tricks, yes. So we're all familiar with, around the holidays, we have obviously lots of tinsel and also lots of styrofoam. And you guys might be familiar with this, right? This kind of magical. So what's going on? The reason it's not glued to my hand at all, it's just that it has a little bit of a charge, and it's being attracted to my hand. So we're just going to play around a little bit with some tricks that one can do with tinsel and stuff like that. Tinsel is mylar, which is a thin plastic that has an aluminum coating. So it's like a conductor, so charge can move along on it. So the first thing I just want to say, we can take a material like this glass rod, and I can remove some of the charge on it here. And then we see that if I take my tinsel here, that it is, it's definitely being pulled toward this, right? And then when it actually touches it, once it touches it, then something weird is going to happen where then it's going to be pushed away from it instead of being pulled toward it. So right now it's being repelled from that. So we could try and understand, okay, why is that actually happening? So this goes to our first graphic, which is that, as I'm sure all of our listeners know, atoms are made of a nucleus that has neutrons and protons. The protons have positive charge, surrounded by electrons way far away compared to the size of the nucleus. So this picture is not to scale. For all atoms, actually, the same number of protons and electrons, so they're electrically neutral. And we also know that if I have opposite charges, they'll attract each other, and like charges will repel. Okay, so that's the first thing. So the second thing is that, okay, well, what happens when I'm actually taking one of these rods? So for example, this is just a PVC rod, and I'm just going to rub it with this. And initially, if we go back to our other graphic here, so initially the pipe, I'm just showing the pipe, but I'm not really showing the charges. And now in the second graphic I show, it's kind of neutrally charged, equal numbers of positives and negatives. But after I do this rubbing, and we might come back later and talk about why do I have rubbing in quotes here, but I actually am putting more negative charge on this. And so now, as I bring my tinsel close to this, now we see that in fact it's definitely it's feeling forces here. It's being pulled one way or the other. Let me just give this a little bit more juice on this thing. Okay, so now definitely we can see that it's feeling a strong force one way or the other. Yes, and so what's happening there, if I go back to my second graphic, is initially when this is far away. Actually, next graphic up. Great. Initially, when this is far away, it's neutral, so it's not really charged. And then as it gets close enough, what happens, the next graphic, is that we start to pull some of the positive charges toward one end and the negatives on the other end. And then the positives on the lower end are attracted to the rod and the other ones are repelled. That's why we kind of see this thing where it's kind of angling in. And then when it finally touches, and we go back to the next one, then we actually get that it is self-negatively charged, and so the whole thing should fly away. So we're going to try and do a demo of that. Okay. I've had different amounts of success today. Okay, so I didn't bring the wool sweater I was
going to say, where's your ugly sweater?
Yeah, well, okay, but I meant to, and I left it at home. But anyway, this is one of your tablecloths here, and this is some styrofoam. So what I'm going to do, I'm just going to
whatever you need me to hold.
I'm just going to charge this thing up by rubbing it. Trying it. This is going to take us a couple tries. Going to put some charge on this. Going to put some more charge on it. Try not to just destroy the whole table in the process. Okay, we're going to give this, hopefully, one more dose here. I want to get enough charge on this. Okay, that sounded pretty good. And now I've got one of my little things here. Okay, so I'm going to just drop this on. Boop. Oh, man. And what I want is for it to get enough charge. I'm going to try one more time. I'm going to try one more time on this one instead. So we're just going to bump this off right out of the way. Awesome.
Thank God it wasn't glass, right? Oh.
Okay. This is real science when you don't know whether it's going to work, Okay. So let's try again with my little thing here. Okay. It's pulled down a little bit. I'm going to let it go.
Oh, it flew off.
We definitely saw in that case that it's flying away, yes?
It won't even stick to it.
Awesome. Great.
Wow.
So that's the power of static electricity. We will talk later on why that is valuable to us, because we actually need it for a bunch of applications like DeskJet printers and things like that. All rely on that. But for now, it can. And we also sometimes want to get rid of it, and we'll talk about how to do that next time too.
And safely, of course. All righty. Thank you, Paul, for all that you brought us this morning.
Thank you very much. Have fun, everyone. Happy holidays.
Yes, of course. Merry Christmas to you and your family, Paul. And of course, we hope you can stay with us on the morning show too, because on the topic of science, the Earth has many layers, and as we turn our attention to agriculture, we're going to share how they're made in this week's Ag in the Classroom.